but you can differentiate it with the accreting fraction and with the infrared. It has a very similar to ytringite, but we could differentiate between ytringite and talmazite. Also with infrared, you can see the frequency with the silicon, which is octahedrally coordinated, and we have 7. This is also talmazite. But we could, and here of course we have the talmazite. And we could have a chemical treatment, and we have prevented the talmazite formation in the SEM2BL treatment. It's going to change all the chemistry and all the production of the cement industry. This is no oil, right? And you have no talmazite. This is a lot of application that we have done in this subject. We have also another part of subject how to reduce by using stabilized soil in the construction. Just leave the concrete, leave the cement and stabilize the soil. And this we have also a lot of experience in it. And we have cast earth, we have also Dr. Arbeit and everything in this here. And there's one disadvantage here, that you have the swelling clay. The swelling clay, you cannot use it because it's going to swell. Now we could find also the chemical agent to reduce the swelling, and of course in this part of the work we are using casters. Casting, like cast concrete. There is no flowability when you have swelling. And when we treated it with CMC, we had better flowability. And of course, in order to work with the cast earth, we have to understand a lot of superplasticizer. And superplasticizer, we had, of course, we have to understand it, how it is competition between all the ions and particles around the hydration pore. And how does it work? From agglomeration to dispersion, and of the mechanism, adsorption, steric effect, electrostatic repulsion, a lot of mechanisms known in cement chemistry. But we could reduce the swelling, we could reduce the length change, we could increase the compressive stress. Also, we have mixes with glass powder. Different mixes with glass powder with the flowability, and we measure the flowability and compressive stress. We have there also cement can bypass test, a lot of work on the cement can bypass test. And a mix of glass with activated clay. Activated clay we use mainly the swelling and not the carbonate. We had a lot of work on the swelling. And also it was successful. Now the green building, you have two main things in green building. Either to work with stabilized soil with architect, we had a lot of colleagues with architect. And we had a very nice road with the stabilized soil in Aswan. Or now we are using with the wooden structure. The wooden structure, we use it also to stabilize soil. And there is a very nice company working in this type of construction, and they took all the approval from HDRC, and this is stabilized soil in the construction. And this is also the and this is one of the first thing which was in Sion that we constructed in stabilized soil. Just to tell you about one thing, which I hope that you are going to take it, we have presented a project with the STGF. STGF, it is the 50 project presented to the STGF, and the Helwan University is I hope it's going to be taken among 7 projects all over the country. But it deals with what I'm saying. Pozzolanic, we are going to see all qualities of basalt, and whether they are okay with the cement and concrete. We are going to see the LC3, all qualities for swelling clay. We are not going to work with the carbonate. We are going to see the ashes cement that we have to burn all organic material with an active surface and use it as ashes cement, and not only concrete, you are using for any application. Accessory road, stabilized soil, you don't have only concrete. And of course, road and bridges. And let's hope to be one of the 7 projects to be accepted. Thank you for your attention.
Thank you. Questions?
No question?
Thank you, Dr. Hannah. Very informative presentation. I learned a lot from it. And also, as you talked about alternative building systems, I see today the cement industry doing great efforts to achieve the decarbonization and lowering the carbon emissions. But I believe we should look at the whole chain and go to the codes, talk about concrete design, reinforced concrete design. They don't care about how cement was manufactured. This is only specifications. So I believe in order to close the gap, everybody has to sit together, cement industry, code officials, and then we can have measures like using lightweight concrete structures, which would reduce like 30 or 40% of the cement and the steel used in those buildings. So cement is only an input to a green building. So let's agree to work together. I see good examples in your presentation. And I believe that concrete design professionals should not judge cement industry. Everyone should be in his own area. I'm a construction management person, so I respect a lot specialization. I should not interfere. Cement industry is doing a great job trying to lower carbon emissions, but we have to do our part in order to have better design, use value engineering, use innovative structural systems. I have seen a lot of systems that reduce at least 50% of the concrete in the building. So those are measures can dramatically improve our carbon emissions.
Thank you very much. And I think we have also cooperation with HBRC, Dr. Khalid Yusuf, Dr. Umayma. اتشرفت بحضرتك وإن شاء الله we are going to have a further cooperation. Any other question?
Thank you very much. It has been a very dynamic and concentrated day. So it's time for us to end sessions for today. We will have coffee and some food outside for you to stay and further network. And we will be back here at 8:30 tomorrow morning for a full day of event. And may I remind you that you have groups to attend to. My leaders of the groups here, so please, what is your group color? Green. A green leader group is here. Please reach out to him. Whoever has green on their chair. Okay? So each chair had a color. Identify yours, and Amr is green. Go ahead. Orange. Orange is this leader. Please stand up so they can see you. Lime green. This is your group leader.